Hello, greetings to everyone and welcome to Acadex Higher Professional Institute. Welcome into today's video, and today in this video we are going to be looking at the solution to the 2017 session of the competitive entrance examination into the College of Technology of the University of Buea. Now this question was sent to me by a student that is going in for this exam, and then I chose to solve it here because it will be helpful to some other students. So now in case you face challenges when solving and you need help, you can just rush to me through the number on your screen now for help. Today in this video, like I said, we are going to be looking at 2017 physics of College of Technology entrance examination, but we are going to be treating just question 1. Now my interest in question 1, which was allocated 15 marks, is to solve the question and solve the problem and explain, so that you understand and be able to solve related questions. Okay, the question reads: the coplanar forces shown in figure 1 below act on an object. Find the resultant force. Now the question that begs for an answer is coplanar forces. What are coplanar forces? Now we need to understand that coplanar forces are forces that act in the same plane. It means that these forces that are acting, perhaps if this be figure 1, then the forces that are acting on this object, we consider the object to be at the origin. Then these forces are acting in the same plane and on this object that is placed here at the origin. So now let's get started with the solution. We shall resolve the oblique forces into their corresponding vertical and horizontal component forces. So now all the oblique forces are forces like this one, 15 Newton force, 16 Newton force, and 11 Newton force that are slanted. So now we have to start by resolving these oblique forces into vertical and horizontal components before we that's the first thing we're going to do. So for instance, we have so that is it. I have just resolved the oblique forces into their corresponding vertical and horizontal component forces. For the sake of explanation, if you don't know how to resolve forces, I mean into horizontal and vertical components, then you can get to me and I'll explain it to you, or in subsequent videos you can comment below in subsequent videos, then I'll explain. Just that I didn't deem it very necessary to explain here. I considered it minor. However, this 15 Newton force can be resolved into a vertical component and a horizontal component. Now the horizontal component, we use actually our knowledge of trigonometry to do this. The horizontal component is given by the 15 itself, cos 60. In fact, I believe we are versed with this, and the 11 Newton force as well, given that it is inclined at an angle of 30 degrees. So we are going to have it into a vertical component of 11 sine 30 and a horizontal component of 11 cos 30, and likewise the same for the 16 Newton force. So after doing that, we are going to have forces in this array. Our new forces are going to be in this array now. We are no longer going to have any oblique force, and then we are going to have these forces these are the forces that are acting at all the edges. These are all the forces. Like we have 16 sine 45 and 15 sine 60 on the positive y-axis. So these are the numerical values here. Now from here we have to sum up these forces to have the amount, the actual force that is acting upward here and the actual force acting downward. And to do that, I'm going to write it in red. We'll have this 24.3. Now 19 plus 7.5, we'll have 26.5 Newton. 5.5 plus 22, we have 27.5 Newton. 11.3 plus 9.53, okay, we have 20 plus 83 Newton. So from there now, we are going to subtract forces that are in opposing direction. For example, these two forces on the x-axis, they are in opposing direction, and the resultant force on this axis is going to be to the right after subtracting this 20.83 from 26.5, and likewise the same for the y-axis. When we do that, we'll obtain something like this. We'll subtract 24.3 from 27.5 to have 3.2, and we'll subtract 20.83 from 26.5 to have 5.67. Excuse. All right, now our resultant force. From here, we have actually resolved all these forces into two components already, but now we have not ended. We have to, our resultant force is going to now be in this direction. Our resultant force will be as such. So now let's draw to indicate the direction of the resultant force. I will name it FR. Yeah. So now this is going to be the resultant force here. Now let's proceed. If the case, we are going to have a diagram like this, such that the vertical force is 3.2 Newton downward and the horizontal force is 5.67 Newton to the right, and the resultant force remains, it maintains its direction. Now we have a right angle triangle, we can actually use the Pythagoras theorem, as it is always the case, to solve for the value of the resultant force. So now let's use the Pythagoras theorem. From the Pythagoras theorem, we have that the resultant force is equal to the square of the squares of both sides, and finally we have that the resultant force is 6.5 Newton. Now you can access past questions and their soft copy PDF and video solutions, or if you need, you just alert me so that we see how to do it. All right. The dates for the exam is fast approaching and it calls for accurate preparation. Thank you for watching the video. If it's your first time videos, do well to subscribe to my channel and turn on your notification so as to be notified when new videos are uploaded to this channel. Do well to like the video, make good comments about the video, and share if you love the video. See you in the next video.